Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. Shop 30 to 50% off Movement's innovative California clean watches, jewelry, and accessories with fast free shipping and returns now at mvmt.com. That's mvmt.com.
Experiences are what people love the most about travel. That's why they love Viator. They have over 300,000 bookable experiences and something for everyone. Plus, their travel experiences have millions of real traveler reviews, so you have the information you need to book the best activities for your trip. Download the Viator app now and use code Viator10 for 10% off your first booking in the app. One app, over 300,000 travel experiences you'll remember. Do more with Viator.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us. This is the Space Nuts podcast. My name is Andrew Dunkley, your host, and with me as always is Professor Fred Watson, astronomer at large. He's got a very big business card too. Hi, Fred.
How are you doing, Andrew? Good to see you.
Good to see you too. I'm well. I hope you're well.
I am, yeah. All fine. Yeah.
Good to know. It's a great way to be, isn't it?
It's better than the alternative.
Yes.
That's right.
Now, I'm going to start off. We got an email the other day from somebody who analyses podcasts, and they have a website that rates them. We are number one in Sweden in astronomy podcasts. I think there's only one astronomy podcast that's actually heard in Sweden. I think we're number one in the Seychelles Islands or the Cayman Islands or somewhere like that.
Cayman, that's right.
Yeah, I mean...
and Ireland too.
Ireland. Hello, yeah. Ireland.
Hey.
It's very exciting because we think about all the big geographic areas that where our numbers really stack up, the likes of Australia, the UK, the United States. But I don't want to forget all those other countries that do listen to us, and a lot of expats or people who don't want to be expats, but they've been forced to be due to unforeseen circumstances this year that are stuck overseas at the moment, who listen to us. So welcome to you. Now, Fred, we've got a bit to talk about. We were going to dedicate this whole episode to questions, but something's happened this week, and we've had a few people actually write into us to say, can you please talk about the Arecibo Observatory? Because the news this week is that it will be decommissioned and demolished after an accident occurred there recently, and it actually happened more than once, the issue that caused problems, and they decided too much trouble to fix, too expensive, and so it at this stage is looking like it's going down the gurgler, but there may be hope. We'll also answer questions about how the Milky Way looks from the Large Magellanic Cloud, heavy elements in the stars, the North Magnetic Pole, and power generation in space. Someone's come up with a really interesting idea on how we might be able to do that. So can't wait to tackle those. But let's firstly look at the situation with the Arecibo Observatory in Puerto Rico. Some very unfortunate circumstances have led to a pretty hard decision about its future, Fred.
Yes, indeed. So, you and I have spoken about, about results from the Arecibo telescope many, many times. What is it? It is a dish in the natural landscape of Puerto Rico, which is basically it's a kind of sinkhole, a natural sinkhole, with this spherical dish built into it, made of metal sheets. 305 meters in diameter. So it's essentially a spherical radio telescope mirror that just looks upwards. Yeah. But you can steer it around effectively with a structure above it, which is what's called the receiver cabin. It's where all the receivers for the radio waves that it's focusing, that cabin can move around. And if I remember rightly, it can look 20 degrees on either side of the zenith, the directly vertical region. By moving this cabin around, you essentially, you're pointing the telescope. And it's an extraordinary structure, not young. It was opened back in 1963. So it's an elderly facility. And, well, we might talk a little bit about what it's done over the years. But what's happened is there has been really a series of events, starting with a Hurricane Maria, back in 2017, that have sort of successively damaged the structure. There were earthquakes in 2019 and earlier this year. But then what's really set the cat among the pigeons is breaks in some of the cables that hold up the structure. It's a web of cables that hold both the dish and the supporting structure, the receiver cabin above it, which, by the way, weighs 900 tons. I was staggered at that. Yeah, yes. So this 900 tons sitting above the mirror. A cable broke back in August, and that caused engineers to look really seriously. So what happened was that cable broke, and some of the debris actually penetrated the metal sheeting of the dish. So basically you've got a hole in the mirror. And whilst the considerations were being given about how to deal with this, earlier this month, a second cable broke. And that basically has, to put it in, I guess, what you might call technical terms, it has threatened the structural integrity of the support structure for that receiver platform, and as well as doing further damage to the dish. And so the decision that's been made is one that is all about safety, because the engineers have concluded that there is no way of making this telescope viable again in terms of its structural integrity without risking human life. In other words, it's an OH&S decision that you can't repair it safely. And that's the always in any kind of engineering situation, the top consideration. What's the risk to human life? If it's too big, you can't do it. And that's basically the conclusion that it's come to. So in fact, it is being closed. And I think the plan now is to try and demolish it safely, so that it will be, I guess, returned. That landscape will be returned to something like its natural situation.
Who actually owns the facility?
So it's funded by the National Science Foundation in America, and it actually owned by the National Science Foundation as well. I think there are probably other smaller funding streams. Some of the programs, like its Near-Earth Object Detection Program, that was, for many years, that was operated by Cornell University. That stopped in 2011, in fact. And there is actually a consortium that is engaged to operate the facility, and that's led by the University of Central Florida. It's a little bit, Andrew, like the way the Anglo-Australian Telescope here in Australia, which was operated by the government department, which I still work for, Department of Industry, Science, Energy and Resources. That department operated the telescope until 2018, but it's now devolved to the university sector. So it's led by the Australian National University, with 12 other universities, I think, who are contributing to the funding. And I think it was a little bit like that with the Arecibo dish, led by the University of Central Florida. Really an extraordinary facility, though, for a facility that is getting on for 60 years old. That it has done the most marvelous science, as well as being a film star. GoldenEye.
It was in there. It was in Contact.
I believe it was. That's right.
Jodie Foster. Yeah.
Yeah. An icon of science, which we never thought we'd ever see the end of, but nature has taken over. And just to, finish up with some of the achievements that it's made, it's really got an extraordinary history in terms of the discoveries that it's made. There's a very nice, point everybody as always to Wikipedia. There's a very nice summary on Wikipedia about the discoveries that the telescope's made. And in fact, within a year after it started operating, it discovered that Mercury revolves on its axis in 59 days, whereas until then we thought it was 88 days. Wow. So, that's a startling discovery to have made at the start of the career of an instrument. And then it goes on with pulsars and the discovery actually of the first binary pulsar. That was a Nobel Prize winning discovery back in 1974. And the list goes on. I think basically we've made it most famous, though, and by we I mean I guess the scientific community, for its observations of asteroids, which are made by radar. So you beam, you ping a radio pulse out to an asteroid and look at what comes back. And because the telescope's so big, you can actually analyze the structure of the asteroid. So we've seen images of near-Earth asteroids, which until then were just points of light in an optical telescope. So that work has been extraordinary, and the list goes on. Detection of molecules, the whole rigmarole of what we expect from radio astronomers. But you probably you will remember, I'm sure. You were just a lad then, but in 1974, I remember this. The Arecibo message was sent. This was a coded message, an attempt to communicate with any extraterrestrial intelligence, beamed towards a globular cluster called Messier 13, which is a cluster of stars. It's about 25,000 light years as the crow flies. And it was a pattern of bits which could only be they could only be turned into an image one way. This is a crude bitmap image that's got stick figures, a picture of the telescope, and really very, very crude compared with, for example, the things that are on the Voyager probes. But that message is still on its way to Messier 13. So, these are the kinds of things that have made this telescope very, very famous.
Yes. Of course, what will happen. Somebody will be listening to their radio on one of the planets at Messier 13 and they'll just switch it off at the 5 seconds before the message arrives.
Yes,
that's what will happen. Is there any chance of saving it? Because I read this morning that there is a petition being sent to the White House to try and urge them to do something to save this telescope, or is it beyond redemption?
Look, that's a question that I can't really answer. The decision has already been made to decommission it because of safety considerations, but it's broken hearts.
I'm sure it has.
The idea of closing it.
The blowback I've read has been astounding. People love this facility. Is it possible, or would it be just too expensive to decommission it, demolish it, and then build a new one on its
again
place? Yeah.
Well, I think what would mitigate against that is, and you and I have spoken as well about this too, that there is now a bigger telescope of a similar kind in China, which was opened back in 4 years ago, a bit more than 4 years ago, July 2016. It's called FAST, and FAST tells you all you need to know. It's the 500-meter aperture spherical telescope. So it's a very similar machine to the Arecibo dish, but 200 meters bigger. And that means, with telescope size is everything. So you've already got a situation where there is an effective replacement. Yes, it's not on American soil or one of the protectorates of America, as Puerto Rico is. It's nevertheless, the scientific community is a very open one. And so, Western astronomers are at liberty to use the FAST telescope in China, and indeed many of them are. The one thing that FAST doesn't have, Andrew, that Arecibo did, is the ability to send radar signals out. They can't do a transmission like you could with Arecibo. So it's very much a telescope that listens rather than pings with radar. But you never know. That might be something that can be added on. It's possible that might be a modification that can be made.
Yeah. Well, it is very sad news, and it will be a terrible loss, but I would think that those that are trying to save it are doing it for nostalgic reasons, probably more so than anything. But that's a good reason to try and save something in real terms. But it'll be a sad loss. But time is never kind to anything, is it?
Especially humans.
Indeed.
I mean, there are other arguments just than nostalgia, because the telescope has always been a draw card for tourism in Puerto Rico.
Yes.
So you've got, there's an economic aspect of it as well, and puts funding into the University of Central Florida and things of that sort. So,
and as you've already mentioned, movies hiring it for scenes.
That's right.
Yeah, it's a real pity. But yes, there it is. At this stage, potential demise of the Arecibo Observatory has been decided upon. You're listening to the Space Nuts podcast with Andrew Dunkley and Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Thanks for joining us. This is the Space Nuts podcast with Andrew Dunkley and Fred Watson. And don't forget to visit the Space Nuts shop. It's on our website, spacenutspodcast.com. I'm having a look at it now. They've got embroidered women's polo shirts. They've got the short sleeve unisex T-shirts. You can put a sticker on the back of your computer if you want to, or the bumper of your car, or wherever you like, over your child's mouth. It can go It can go anywhere. And there are so many more things. He doesn't like that idea. There are so many more things in our merch shop. So when you visit the spacenutspodcast.com website, just click on the shop tab and you'll find all sorts of things there. Of course, there's also a book section. I don't know what's in that, but you could have a look and see what you could find. Christmas is coming up, and maybe someone in your family is extremely difficult to buy for. Well, here are some ideas. So T-shirts, polo shirts, mugs, caps, you name it. They're all at the Space Nuts shop. I never thought I'd see the day, Fred, when we had a Space Nuts shop, let alone a Space Nuts podcast, but there it is. Now, we've got some questions to tackle. We're going to try and dedicate much of the rest of the program to questions. And our first question comes from Brian in Georgia. Now, before we do that, I'm going to upload the audio for the questions the way they used to do it in the early days of radio. See this? I'm going to put it over there and hit play. So if this all falls over, you'll know why.
Hey, Andrew. Hey, Fred. My name's Brian. I come from Warner Robins, Georgia, USA. I'm a big fan. I really appreciate everything you guys do. Your podcasts have saved me my sanity on my long drives for work. I do a lot of traveling. But anyways, I had a thought the other day. Was looking at the large Magellanic and small Magellanic clouds that kind of orbit the Milky Way, and I got to thinking, and we can see these clouds from the southern hemisphere, or these dwarf galaxies, but what do you think that they see in their night sky looking towards the Milky Way? Like, would the Milky Way, fill up their view? Like, how large do you think it would be in the sky of a planet in one of those galaxies? Like, I don't know, just kind of a thought experiment. I don't think I've ever seen anybody visualize this before, and what our world or what our galaxy looks like from someplace else. And I don't know, just kind of an interesting thought. And I just wanted to see what you guys' thoughts on that might be. But anyways, awesome podcast. I appreciate you guys, and enjoy the weather. Now it's getting warm over there for you, so stay cool.
All right. Thank you, Brian. Yes, in terms of getting warm, we're headed for 43 this Sunday. 43 degrees Celsius. What's that, about 1 million in Fahrenheit? It's a lot.
40 is 100. I think 40 is 106. Is that right?
Yeah, well, we're going to go well past that.
Yeah.
Well past that. Yeah, the view of the Milky Way from the Magellanic Cloud district. At this stage, we can only look back from as far as the Voyager probes have gone, which doesn't give you that view.
Not quite.
Not even close. And so we can only go on our knowledge of ourselves from within and create artists' impressions. But it's not going to be all that far off the mark, I wouldn't think, with the knowledge we have.
That's exactly right. In fact, I haven't taken the trouble to look, but I bet we could find simulations online of what our galaxy would look like from the Magellanic Clouds. Let's just revisit what the Magellanic Clouds are. They're two neighbouring dwarf galaxies. They're large dwarf galaxies, but they're our closest neighbours of any size in the local universe, the local group, which is what we call our part of the universe. The big one, the Large Magellanic Cloud, is 165,000 light years away, thereabouts. The small one is both slightly smaller and slightly further away, about 200,000 light years away. So they look, the smaller one looks smaller, partly because it is, but also because it's a bit further away. And they are relatively rich dwarf galaxies. In fact, the Large Cloud, when you look at it with really deep imagery from Earth, you can see there's a kind of there's a bar to it and just hints of possible spiral structure. But as Brian rightly says, they are kind of orbiting the Milky Way, but also being demolished by the Milky Way. The tidal effects of the Milky Way galaxy's gravitational attraction is pulling them to pieces. So they're not going to be permanent features. So now let's put our imaginations onto a planet orbiting a star in, say, the Large Magellanic Cloud. What do we see? Well, you see the Milky Way, and it will be relatively bright. It will be much brighter than we see the Large Magellanic Cloud in our skies. And we see it from here in the Southern Hemisphere, of course, partly because the density of stars, certainly in the central region of the Milky Way galaxy, is much, much greater than it is in the Large Magellanic Cloud. So there'll be this beautiful blob of stars. You will be able to see the bar of our galaxy, because we know that it does have a barred structure across the middle, and then the spiral arms. But it won't be exactly face on. In order for us to be able to see it face on, the Large Magellanic Cloud would have to be at the pole of our galaxy. In other words, exactly at right angles to the galaxy, and it's not. You and I can probably both envisage what it looks like in the sky. The Milky Way is, I guess it's about 40 degrees from the Large Magellanic Cloud. I'm just thinking aloud here, but something like that. So what you're going to see is our galaxy tilted at about 40 degrees. So it will look like an ellipse rather than like a circle. Probably similar to the way the Andromeda galaxy, M31, looks to us, but much, much brighter and covering a much bigger chunk of sky. It won't be the whole sky. Brian, says what is it going to look like in the skies of a planet on one of those Magellanic Clouds or in one of those Magellanic Clouds. It will be not the whole sky, but it will be a large chunk of it. It will be the single most spectacular object in the night sky of a planet there. It's a very nice thought to have. And if I get time, I'll try and hunt out some simulations and see if we can mention them next time.
Yeah. And we've talked about our view out into space. And I think it was me or someone asked the question as to whether or not it would be different if we were to jump over to Mars. And the answer was not much.
Not much, that's right.
It would be negligible. You have to travel quite a long way to get a different view in space.
Yeah, you do. And, you might remember it's a few months ago now, the New Horizons spacecraft took some images of, forgotten which star it was. Yeah, it was Alpha Centauri, and compared them with the view from Earth to get the effect of parallax. And there is just a tiny difference in their positions, even though it's, 7 billion kilometres away or something like that. Yeah.
It's quite incredible to think about, isn't it, with that sort of perspective? I mean, here in town, you can drive from one end of the street to the other and the view is completely different. Yeah. In space, doesn't work that way.
Don't work like that way. No, that's right.
Brian, thank you for your question. Now let's move on to our next question. This is from, we're going to say Glyn.
Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Because we got a system that not only records your audio when you send in your questions, it actually transcribes it. But sometimes it calls people weird names. So it could be Glyn from Albion in Victoria.
Good morning, Andrew and Fred. Love the show. Keep up the good work. This is Glyn from Albion in Victoria. I have a question on stars. I know that they're made from gas clouds and it's mainly helium and hydrogen, but what happens to heavier elements when the star is made? I know with the Earth, all the heavy elements have gone into the core, but what happens in a star? Are they expelled straight away? Do they go straight to the core? Do they ignite? Just a question. Thanks. Bye.
Thank you, Glyn.
Yeah, it is. It's Glyn. Hi, Glyn.
Thank you, Glyn. Heavy elements in the stars. It's a question that's way beyond my brain.
Yeah, it's a bit beyond mine too. But you have to think about what's going on in a star. And principally what's going on is hydrogen is being converted into helium, but there are, by nuclear processes, there's a whole suite of different nuclear processes that generate these the elements. Starting with helium. Eventually, in normal stars, you get to the heaviest of the elements, which is iron, which is produced in relatively small quantities compared with the main burning that's going on, the main nuclear processes. Now, all this is happening anyway in the core of the star, because that's where the temperature is high enough for the nuclear fusion to take place. And the internal structure of a star is quite complicated. So you've got the core where these things are being produced, the elements are being produced, and then there are various convective zones of mostly hydrogen again above that, and ending up with a photosphere, which is the surface that we can see with a star. So the bottom line is that those elements are already in the core of the star as they're being made. And it's, the really heavy elements, the gold and platinum and things of that sort, they are only produced in very highly energetic situations. For example, a supernova or a neutron star collision. That's what generates those much heavier elements. And they find their way into interstellar space and eventually find their way into planets. And yes, exactly as Glyn says, they go into the core, which is why our planet has a core of nickel and iron. It's all the heavy stuff's gone to the middle. But in a star, whilst the nuclear processes are taking place, they're in the core anyway, just because that's where it's happening. With a star like our own, which will essentially start shedding its outer atmosphere as it ages, because it runs out of hydrogen, so you get to a phase called helium burning, and so it starts a whole different set of nuclear processes. I think it's a really good question, because what the end product of a star of the size of our own is a white dwarf, which is where the elements are held apart only by the pressure of electrons. It's called electron degeneracy. And I assume most of the heavy elements that have been created are still in the core, but some of them at least must go into the outer envelope that is spreading out to form what we call a planetary nebula, a glowing disk of gas. There will be heavier elements in there. So it'll be a bit of a mixture, really. It's a really great question. And one that I guess the answer really is that you can't compare a star and a planet. With a planet, it's dead simple. They're differentiated, so all the heavy stuff goes to the middle because gravity is the main force that's going on. But with a star, you've got gravity competing against the outward pressure of nuclear fusion, and so the radiation pressure. So the situation's a little bit different.
And it would be different from star to star because there are different classes of stars. They all have different ways of acting and different ways of reacting, I suppose.
Yes, indeed, that's right.
Yeah.
Although the overall structure of a core and an envelope, a convective envelope, and then the photosphere, they're the main constituents of most stars.
Mm. Okay. Glyn, thanks for the question and very high quality microphone, may I say. That came through beautifully. So I don't know what you used, but really, really good. Yes, thank you to Brian and Glyn for providing those questions for part 2 of the 230th episode of the Space Nuts podcast with Andrew Dunkley and Fred Watson. I don't know which side he's on. One of them. We'll be back in a moment.
Space Nuts.
This is the Space Nuts podcast, episode 230. Andrew Dunkley and Professor Fred Watson. And we're trying to cram in a few questions this week to catch up because we got an avalanche of them the last couple of weeks and even more, as it turned out yesterday. We're going to maybe do this for a few weeks to do a bit of catching up because you put the effort to send questions in as requested. It would be wrong of us not to try and knock a few over. Some of them might cover topics we've already covered, so we may well not go there again, but we'll just see how it goes. In the meantime, don't forget, if you want to support the Space Nuts podcast, you can do so through our website. Just click on the Support Space Nuts button, top right-hand corner, and that will open you open links up to Patreon. We've got a lot of supporters through Patreon. Supercast as well is another option. It's similar to Patreon, but you can get package deals through Supercast, so you can get 2 or 3 of our stablemate podcasts for a monthly price. You can even now through Patreon buy 12 months for the price of 10 ahead of time. So that's an option. Or you can just make a one-off donation through PayPal. So there are plenty of ways of supporting the Space Nuts podcast. But as I always tell you, it's optional. We're not expecting you to do it. It is totally up to you. We appreciate that you're listening, and that's the most important thing. Now, Fred, let's move on to our next question. This comes from Snow in New Zealand, and they do get plenty of snow down there from time to time.
Hi, Fred and Andrew. Been listening to your show now for a fair while. Absolutely love it. Look forward to it every week. My question is the North Magnetic Pole actually in Antarctica, not in the Arctic? I understand when you look at a compass and the needle points towards the north, I understand that it's pointing towards the North Magnetic Pole of the Earth. If you do the same with a magnet and float a magnet with a north and a south pole marked on it, it points into the same direction as your compass does. But my reasoning is if like charges repel and dislike charges attract, that would only leave the true North Magnetic Pole is coming out of the Antarctica and not the Arctic to make the compass direction thing work properly. Please answer this. I've been thinking about this for a couple of years. Love the show. Thanks, mate. This is Snow from New Zealand.
Thank you, Snow. You see what sort of things people start to think about in lockdown? I would never even have contemplated a question like that. It's a very interesting one, as most of our questions tend to be. But is he on the money, or is he got it all flipped over?
It's a great question, and thinking about it. So if you have a compass, the needle. If you think of a compass with a needle that's magnetized,
yeah, which I used to make as a kid. Stick them in a cork.
Yeah, it's a really good point. So the bit that points north must be the south pole of the compass. I need to do some experiments on this.
Yeah.
I mean, it's a matter of it is a matter of nomenclature, and the magnetism of the Earth is a complex and wondrous thing. It's as you know, the magnetic pole's racing across the Arctic at the moment, the North Magnetic Pole. But it's true enough that a needle that's pointing north must be the South Pole of the compass needle, and so you've got the slight dichotomy there. I hope I'm not talking rubbish here. I've never thought about this. Just like, just like snow.
Well, it's been troubling Snow.
I know.
Thinking about this
it's troubling
for a while.
me as well. In a sense, our whole business about magnetism is the fact that it is a bipolar phenomenon. In other words, there are two opposite effects. There's what we call the north and south poles, and the like poles repel and unlike poles attract. So that's the bottom line. And the same is true with electricity. You can have positive and negative electrical charge. So you've got the same sort of phenomenon. That's all part of the electromagnetic force, which is something that's actually carried by photons. But where this gets really interesting, and rather than just being a question of nomenclature, which is really what we're talking about with these north and south poles, it gets really interesting in the situation of gravity, because so far as we know, gravity is a monopolar thing. You only have one way. Things attract each other by gravity. So there isn't a negative gravitational pull, something that will react by being pushed away. Gravity is the least well understood of all those fundamental forces. We don't have a quantum theory of gravity, so we don't know what gravitons might look like. Eventually it will come. I think this is one of the most exciting branches of physics, to try and figure out how gravity works. But if you sort of think about what we might learn about gravity, supposing we did discover that there were negative gravitational poles, then suddenly you've got a brilliant way of shooting things through the universe.
Yes.
Because you get something that reacts negatively to a mass, switch it on, and away you go, bashing through the universe at high speed. So that's drawing a long bow from Snow's question, but it is an interesting aspect of it. And thank you for the question, Snow. I never really thought about that.
Yeah. I mean, we talked about the North Magnetic Pole being on the move. I think at last report it was in Siberia, wasn't it?
That's right. And there are different versions of the pole. There's is it the geomagnetic pole is if you just interpret the Earth as being a bar magnet. But then there's places where the dip lines are vertical, where the magnetic field is going vertically down into the Earth, and that gives you, a different pole. So I think that might be the one that's racing around up there in Siberia, getting out of control. But thanks for the question, Snow.
Indeed.
Yeah. It's
good to hear a New Zealand accent on the show.
Lovely,
So we've done all three now. We've done UK, Australia, New Zealand. We've got the whole set on this week's program.
We've got yes, we do. But we don't have Sweden yet. We've got listeners in Sweden and in other European countries. We'll get to your questions when we can.
Indeed, we will. Now, let's move on to our final question for this week. This one comes from Damien. I'm going to guess this will be an Australian accent. What do you think? Let's find out.
Hi, guys. I have a question about generating power in space. On Earth, in many places, we use thermal power plants. Why aren't we using them in space? A satellite's typical range of temperatures was found to be from -170 to 123 Celsius for LEO satellites, while -250 to 300 degrees for different orbits. A spinning hourglass with refrigerant gas would be heated and cooled as it rotated around. Add a turbine into the middle of it and you have a power source. Add multiple hourglasses and control the speed of rotation to optimize the heating and cooling. I gather it depends on the radiant heat loss, as space is a good insulator, and the performance compared to solar. Regards, Damien.
Well, that's a fascinating thought. Power generation in space. Is he onto something that would be feasible?
Yeah, I think it would work. What Damien suggested, I think it would work. It is absolutely right that you've got this, these huge temperature differences. The thermal control of spacecraft is one of the biggest problems. How you keep them at a uniform temperature for their electronics to work and things of that sort. So the side facing the sun is warming up very quickly, while the other side is radiating out to space. It's just by radiant heat. So there are large temperature differentials, and maybe you could do the kind of thing that Damien's suggesting. But I think the bottom line with this question is that, and people have obviously looked at this sort of thing very carefully, that it's much more efficient to have simply a solar panel that works on the photovoltaic process to generate the power directly and rule out the mechanical components.
No moving parts.
No moving parts, that's right, just electrons moving around. Solar cell technology is now at such a level that we're getting very high efficiencies, both here on Earth and in space.
Well, I know that. My electricity bill turned up last week. It was $1.50.
There you go. Yeah,
I've got some good gear up on the roof.
You've got good gear on there, and you don't have spinning turbines. You've just got direct conversion from of light to electricity. Yeah, great stuff. Right. Well, a good question, though, Damien, and I love the idea. Turbines are among my most favourite things, but sometimes they're not the most efficient.
I suppose it also opens up the question of where power might come from into the future, because, converting sun power into electricity is something we're doing really well now. And if you've been around my district, you will have come across a myriad of solar farms. There are some massive solar farms in this part of the world generating electricity enough to power a small town. You make enough of those, but the trouble with them is they are so massive to generate enough electricity for 4,000 dwellings, for example. It sort of starts to become a bit of a problem when you need to generate electricity for 4 million homes, for example. So you'd need a multitude of solar farms. So we can't rely on that totally, but there's also wind power and river flow power, hydroelectric power, if you like. There's all sorts of other ways, but who knows what might be an option into the future? Fusion power. I know that's going to start a lot of debate, because a lot of people are very much against nuclear power, particularly in this country. But they're, to probably throw the first punch. They're basing that on 2 or 3 incidents in the history of nuclear power generation in the world. One of which was caused by a natural disaster. The other 2, one was caused by an accident, and the other was a small meltdown. But how many nuclear power stations are there in the world you never hear about because nothing ever goes wrong? Just throwing it out there.
Yeah, when you look at the, since we're talking about this, we've got off topic a bit, but when you look at the risk to human well-being for different energy sources, the riskiest of all in terms of potential loss of life is actually hydroelectric, because if you get a dam bursting, then you can lose tens of thousands of people. That's just figures from,
and that has happened historically.
Yes, it has. Yeah,
and not long ago, I think 1 or 2 years ago, the dam in the United States was splitting and released a lot of water. It can happen.
Yeah. Anyway,
and over the course of time, it probably will. But his thoughts steered me down that path.
Yes, I can tell. Going up into space, though, really the best option, certainly for the inner solar system, is solar power. It's solar panels. And we see that even, I think Juno, the spacecraft that's in orbit around Jupiter, has the biggest solar panels ever launched into space because it's so far away, but it's still using the sun's energy to generate the electricity for the spacecraft. Once you get beyond that, though, you really need an independent source, which has been, to date, it's been these RTGs, the radioisotope thermoelectric generators. And it's hard to get away from that. So thinking about what, future explorers of the solar system might do when they get really to the depths of space, it's really got to be something like a nuclear power plant. Fusion power is much safer than fission power. It doesn't exist yet. We've been trying to make a fusion generator for 50 years. There's an establishment called ITER in southern France, which is where a huge experiment has been going on for nearly all that time at the European fusion reactor. They've been within 5 years of making it work for about the last 5 decades. And eventually it will work. Eventually it will.
They should watch Back to the Future and chuck in a couple of cans of Coke and a couple of banana skins.
And she'll be right.
I bet they haven't tried that.
No. Anyway, fusion power is the future, but it might still be the long-term future.
Yes, indeed. Well, it's going to be interesting, whatever they do, but they do have to solve the problem of using fossil fuels going forward, and
quite so,
and the intensity that is required to create electricity through those systems, and even hydrogen, which is in development. That requires a lot of effort as well. A lot of energy needs to be expended to create the liquid hydrogen to fuel cars. But they're certainly looking into it. But electricity seems to be the way to go at the moment when it comes to vehicle or the future of vehicles. That brings us to the end. Thank you to Damien, Snow, Glyn and Brian for their questions this week. We'll get some more questions knocked over next week. Don't forget, of course, if you do want to send in a question, it'll be now part of a backlog, but you're welcome to do so through our website. Just go to spacenutspodcast.com, click on the AMA tab, and if you've got a device with a microphone attached or built in, that's all you need to do. You just press start recording and start talking. Tell us who you are, where you're from, ask us your question, and away we go. And they'll send them all to us, and we'll add them to the program. Well, as many as we can anyway. So thanks again. And thanks for listening. And thank you, Fred, as always. It's a great pleasure. Good to see you again.
Yeah, you too, Andrew. Take care, look after yourself, and see you next week.
All right. Professor Fred Watson, part of the team here at the Space Nuts podcast. We also thank Hugh in the production studio for doing all the button pushing and blowing all the bells and ringing all the whistles. Or is it the other way around? Anyway, and from me, Andrew Dunkley, thank you again for listening. We'll see you on the next edition. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.